Okay, so 1.4 arithmetic sequences in series. We are going to interpret them and add them, subtract them. We did some arithmetic last year. So let me see. Okay, so a sequence. A sequence is a list of numbers formed by a common rule. A sequence is a list of numbers formed by a common rule. A rule in math is an equation, correct? Or a formula. A rule, a formula, an equation, all the same thing. Do you guys want light?
No.
I'm good. Nick, you good? Because you're furthest back. Okay. Arithmetic series. Okay, so there's two things there. There's an arithmetic and there's a series. So you have to know what both those are. A sequence with a common difference, and the variable we will be using for that is D, between two consecutive terms. So a sequence is a list of numbers a series is a list of numbers, but what happened between them? What did I change? It's addition. You're actually putting the sign of the number. So it could be subtraction. If it's a negative number, it'd be subtraction. And I think I've said that to you guys before. There's no positive and negative numbers. It's just addition and subtraction. Actually, there's no addition and subtraction. It's just your integers, whether it's positive or negative. So then I have the sequence. Is the sequence arithmetic? So before we start that, I'm going to go back. I guess I jumped. So common, what's it mean? What's common mean?
Does it say difference?
Okay, it's the same, right? Okay, difference does not always mean subtraction. Difference just means the difference between the two numbers. Okay, it's the same amount. What? Oh, I thought you were. Okay, so I have 1, 3, 5. What is my common difference? 2. So my common difference is 2. What if I had 5, 3, 1. What's my common difference? Negative 2.
Choir students might be a little late in class. Junior high choir students might be a little bit late to their next class.
Okay, so common difference, it does not always have to be positive, does not always have to be negative, but it does have to be common. Okay, difference is an addition, subtraction. It is not a multiplication, division. So, is the sequence arithmetic? If so, what is the common difference? And what is the next term in the sequence? So, how am I going to figure out what their common difference is? Subtract. 8 minus 3 is 5. 13 minus 8, 5. 18 minus 13. 23 minus 18. 5. Did I have to do all of them? No. Yes, you did.
No. There's
Okay.
5.
Okay, as long as you have to check all of them. I didn't have to write them all out, but do I have to check all of them? Yes. Because what if I had a 5, 5, 4, 5? Then it's wrong. Now, if I got 5, 5, 4, 5, I'd probably go back and check my work on my 4, right? But could I throw that out at you just to throw you off? Yes. So, do I have a common difference?
Yes.
Yes. My common difference is 5. So, does that make it arithmetic?
Yes.
Yes. It is. Okay. So then it says, what is the next term in the sequence?
28.
28. Know how we do this is a sub 1 sub, so it's little, is 3. A sub 2 is what? 8. This is the number in the sequence. So this is 1, 2, 3, 4, 5. What do we find? 6. So a sub 6 was 28. So all these numbers mean something. The little 6 means it's the 6th term in the sequence. It also means once you know the equation, which you're going to have to find yourself, when I plug in 6, I better get out 28. Okay, we're good? Right there, 8 minus 3, 13 minus 8, 18 minus 13, 23 minus 18.
Wait. Why?
Because you have to see if they're a common difference. So how do you find the difference between two numbers? You take the second one minus the first one. Yes?
Yeah, but how do you get 28?
Because my common difference was 5. So if I have 23, what's my next number? Plus
Okay,
5.
yeah, mine was the one 8, 10. Okay, hold on.
What?
Six to one.
That's the 6th term. Because I gave you 5 terms, so that's the 6th term.
Wait, why did it have to be an A? Was A really?
Just A is what they, because it's A is what they use.
Okay.
I honestly couldn't tell you why.
So do you just put like the next number that they don't have for it?
What do you mean?
Well, like if you're answering the question, do you just put?
Yeah. So if there was 7 there, we'd have A sub 8.
Okay.
A lot of them will say, give me the next 5 terms.
Okay.
Okay. So then you would say 6, A sub 6, A sub 7, A sub 8.
Okay.
Okay? Are we good now? Okay. So how could you write a formula for finding the next terms of the sequence? So how did we, like if I wanted a formula, how would you tell me to write that formula? What would you write down?
X plus
X
5?
plus 5.
Just X plus 5?
Yeah.
Okay, but if I just wrote X plus 5, okay. So you want me to write X plus 5. Oops. So X plus 5. So we did A sub 6, right? So I'm assuming you're meaning 6 for the X. Well, 6 plus 5 is 11. So that doesn't work, does it? Because what do we know it is? We know it's 28, right? So what do you think?
A6 plus 5.
Well, A sub 6 is 28. But we have to get from 23 to 28. So how do we get from 3 to 8, from 8 to 13, from 13 to 8, 23 to...
We add 5 to the last number.
We add 5 to the previous term, didn't we?
Yeah.
Okay, so we did these last year with geometric sequences. And so we're going to use, for this 6, we're going to use an n, meaning the nth term. Okay? So A sub n equals, well, if I want the 6th term, I had to use the what term? The 5th. Okay? So I'm going to write A sub n minus 1. So if I wanted 6, would n minus 1 be 5?
Yeah.
Yes. And then we added what?
5.
5. Now does this work?
Yeah.
So A sub 6 equals a sub 6 minus 1 plus 5. Well, 6 minus 1 is 5 plus 5. So what is a sub 5? 23. So 23 plus 5 gives me 28. So did that work? Okay. So this would be the formula. We call it a formula. We call it a rule and a definition. Okay, so we can call it any of those things. Now, would this be an efficient method to find the 100th and second term? 102 cents. Why?
Because you probably don't have that high. You have to have it one less than.
So in order to get the 102nd term, I have to have the 101st. And in order to get the 101st, I have to have the 100th. So is this very efficient?
No.
No. Can I get the right numbers?
Yeah.
Is it going to take me a while?
Yeah.
Yeah, a long while. But this kind of definition right here is known as a recursive definition. What word should recursive remind you of?
Reciprocate.
Cursive. How about reoccurring? Yes?
Oh.
Are we having to bring up the previous to get to the next one?
Yeah.
Yes. Okay. These are called recursive definitions. Each term is defined by the operation on the previous term or terms. It could be more than one term. And actually, I'm going to do this because that means singular or plural, correct? So, recursive definitions are manageable but not efficient by all means. Most formulas that people start with is they start with something recursive and then move to what we will call explicit. So when I want the 102nd term, I just plug in 102 and get out what I want. I don't have to find 101 terms before that because that would take forever. Yes? But I have a question for you. This definition that we made, we just said it needed the previous term, yes?
Yeah.
So how would I get the first term?
Yeah.
I can't get the first term, can I?
Nope.
So do I have to tell you the first or where to start? Yeah. So we're going to add it. See how I erased my box? We're going to add a sub 1 is 3. So this definition has how many parts to it? Does it have one part or two parts? Two. Okay?
Wait, why are you writing that?
Because if I didn't have that a sub 1 is 3, could I get 3?
I mean, I guess not. So you just have to write it out even though like it gives you it?
Well, but if I didn't give you this and I said write the sequence with this definition, could you do it? If I didn't give you this and I said write the sequence,
No, because
because you don't know what to add it to, right?
Yeah.
So I have to give you a starting point. So a recursive definition has at least two parts. It could have more. Okay? So you might want to add at least how many parts? Two. And those two parts are starting point and I'm going to say initial condition, but you guys won't remember what that means, will you? And equation. And how you read these equations, because that's n minus 1, you guys will like, I don't even know what that means. When I see that, I think recursive, and what am I doing to the previous term to get to the next term? So look at this. What are you doing to the previous term to get to the next term? Adding 5. That's all you got to tell yourself. Don't overthink it. Okay? This underline tells me it's recursive, and this tells me I'm doing what? Adding 5. So you start with 3, add 5. Don't get all messed up with a lot of things in the definition. Okay? Am I good? Okay, so are the following sequences arithmetic? If so, what is the recursive definition and what is the next term in the sequence? So we're going to do A, and then I'm going to make you do B on your own. Okay, so how am I going to check if it's arithmetic?
Subtracting the first one.
The second minus the first?
Yeah, second one.
Okay, second minus the first. So between 20 minus 25 is what? Negative 5. 15 minus 20? Negative 5. 10 minus 15? Negative 5. So as far as I know, is it arithmetic? Yes? Okay, so arithmetic. And my common difference, we just put a D, is what? Negative 5. Okay, so then our definition, remember we have to give an A sub 1 a starting point. So what's my A sub 1? 25. So then I have A sub n, it means any other term. You have to start with the n minus 1 term, meaning the previous term, right? And do what with it? Subtract 5. So this is your whole definition. You cannot have just one of those. You have to have both. So try the next one on your own.
That would be our final answer.
Yes, the boxed would be your final answer. Well, all of it is because it asks, is it arithmetic? What's the common difference? But like the definition would be the box.
So then what do you do if there's no?
Is it?
No.
No. Could I stop after the 2 and the 3?
Yeah.
Yeah. Would I check my work? Yes. But as soon as you get 2 consecutive ones that are not the same, do you keep going? No. So it's what?
No.
Not arithmetic.
And then we just stop there.
Yep. Because you can't write a definition if it's not arithmetic. You don't have anything common. Okay, now, do I have to show this? I have to write the list of work. I'm in my workbook. I'm in my book, and I'm doing my assignment. I have to write this. Yes, that is the problem. I have to write this. Why? That's my work, right? You didn't have to put 4 minus 2, 7 minus 4, because I should be able to figure that out, correct? And then here is my answer. Okay, we need to, I'm pointing that out because I'm getting some work that I'm like, where's your work? I got to see your brain. And I don't want brains on the paper. It's gross. Okay, we did recursive definitions and we said those are not very efficient, right? So why don't we do an explicit? Explicit definition means allows you to find any term in the sequence without knowing the previous terms. That would be nice, right? Okay. This is the most efficient way to go about it. So an explicit definition allows you to find any term in the sequence without knowing the previous terms. So this definition for arithmetic is a sub n equals a sub 1 plus your common difference times n minus 1, the quantity n minus 1. Then you would distribute your d and, yep, that is the equation. And you have to know it. And my advice to you is to write it every single problem today until you do. I'm serious. You have to know it. I will not give it to you on a test. I can guarantee it will be on the ACT. Guarantee it. I will guarantee that you see it next year, and the year after, and the year after that, and the year after that, and the year after that. Should it be very hard to learn? No. A sub 1 means the first term, correct? So A sub 1 is the first term. D is what? What's it stand for? Common difference. Do I have to put common? Yes. What else do I got in there? Oh, and N. What's N mean? The number of the term. So like if it's the fifth term in the sequence, N is 5. Okay? And A sub N is the actual term. Is the value of the term. How about that? Does that make more sense? So N is like what number the term is in the sequence. A sub N is the actual value of the term. Does everyone get the difference between those two things? That's usually the thing people struggle on the most. So I need 4 parts. There are 4 different parts of this equation. In order to write it, I need how many of the 4?
2.
3. Don't I need 3? If I have 4 parts of an equation, 4 variables, don't I have to have at least 3 to write an equation? Yes, because you have to have an unknown. Correct? Okay, so this is it. This is what you're going to work on to remember. I hate when it highlights because you can't read it. But that's it. You got to know it, correct? Okay, so we're going to go through here. And we are going to write an explicit definition for what we have. So we're going to start by writing all this stuff that we know. Okay? So A sub N we're not going to know because we're writing an equation, correct? Okay? A sub 1, so what is A sub 1? 25, the first term. Okay? N, we're going to leave N. We're not going to mess with it because it's an equation. So we need to know the difference. 5? Minus 5. Why is it minus 5?
Because you're going down.
Because you're going down. Okay, I didn't ask you to show any work because that's not what I'm asking you, is it?
No.
Okay, so now I have these 2 things. I'm going to plug them into here. So I said write it every time I use it, right? So we're going to write it. A sub N equals A sub 1 plus D times N minus 1. So A sub N is going to stay A sub N because we need an X and a Y, don't we? Okay, so I have A sub N equals, what's A sub 1? 25 plus, what's D? -5. Ooh, then I don't want plus. Just put minus 5. And then N minus 1. Okay? Sometimes the book allows you to leave it like this. IXL will never allow you to leave it like this, and neither will I. What should I do at this point? We're not solving. What did you say, Colton? Distribute my -5. So I get 25 minus 5N. Plus 5. Now I'm not quite done. Why not? Combine like terms. So what do I get? 30 minus 5N. Now, could I write it A sub N equals -5N plus 30? Yep, that's my definition. Are both of those the same? Yep, they're both the same. I personally will try not to put a negative in the front, but if they're both negative, I'll put my variable in the front. Why do you think I try to put the negative variable at the back?
So it looks better.
Looks better. Also, then we don't forget about the negative, correct? Okay, but if they're both negative, I will put it always in order. You should always have them in order. Yes, but sometimes we throw those negatives in the back. I'm not going to count it off. I don't care where you put it as long as it's right. Got it? Do you want to try the other one by yourself?
Yeah.
Okay. Mm-mm. Mm-mm. Mm-mm.
We're doing it too.
Well,
Oh, yes.
2 minus 2 is 0, yes?
When you like multiply the two with the n minus one,
You put the minus one up there.
Because you have to distribute.
Wait, you should put plus one or minus one?
oh, yeah,
Yeah, that's good.
so it's just a singular
It's just 2n.
So it's just 2n. Okay, how'd it go? Good? Okay. Questions before we move on? Okay. For the recursive definition. Okay, for the recursive definition. See how this is recursive? Why is this recursive?
Because
Now, they wrote it a little different than I did. Okay? They wrote when n equals 1, it's 45. Isn't that the same as a sub 1 equals 45?
yeah,
Yes, they wrote it a little different. But is it any different? No. And then this just says for every other term other than 1, doesn't it?
yeah.
Okay. So, we have a sub 1 equals 45, and then here's my definition. So what am I doing every time? Subtracting 2. Okay? So, I have to write an explicit definition. So what was my explicit definition? Let's see if we can write it without looking. A sub n equaled...
A sub n equals a sub 1
Minus.
no,
plus
plus
d
b
Oh, I thought
in parentheses
n minus 1. Okay, I just wanted that one. Okay, so that's going to be my explicit definition, yes? So the thing I needed was a sub 1 and d, yes? So what is a sub 1?
45.
45. And what's d?
negative 2
Negative 2. How do we know it's negative 2?
because it's subtraction.
Because it says you're minusing 2.
Yeah.
Minusing. Love that word. That's not a word. Okay, so write me a definition then. Did you get a sub n equals 47 minus 2n?
Yep.
or negative 2n plus 47. Okay, so what?
Okay, I'm still confused how you got, like, how do you know 40?
Oh yeah, I got 47.
Because it says negative 2 right here. Because it tells me right there. Okay, so now it wants explicit to recursive. Well, when I look at this is this, correct?
Yes.
So this is a sub 1.
And that's the common.
And what's my common difference? 7. So a sub 1 equals 1. Correct? And then what am I doing every time? Adding 7. So a sub n minus 1 plus 7. If you write it my way, you don't have to write these domains. But does it say the same thing either way?
Yeah.
Yeah.
So we can just write it that way.
The way I did. This way? Yep. And I guess technically it should say a sub n equals over here outside the curly brackets.
Do we have to write that?
Yeah, let's do it. Because it makes it an equation.
Right, what?
The a sub n right here. This part. Can I switch real quick to see what I have that we're not going to get to yet? Okay. Now, I don't think I know your assignment is online. I think it is 5 to 11. Okay? We did not get anything to a sum. Like finding the sum. If that 5 to 11 includes a sum, don't do it. Okay? Got me? But your assignment is in Google Classroom. Thank you guys. You did very well during notes today.
Can you go back one slide really quick?
Um,
So I can write down